Okay, on problem number 1, it says that it wants you to use the vertex and intercepts to sketch the graph of the quadratic function. So give us the equation of y minus 1 all equals x plus 2 squared. So to find the vertex, you're going to have to find the solutions to those two equations. So notice here's my equation x plus 2, and here's also my equation y minus 1. I go ahead and solve each one of those equations. And when I solve the x plus 2, I'm going to end up with x equals negative 2. And when I solve the equation of y minus 1, I get the equation y equals 1. That's the location of your vertex. And so since that is in standard form, your vertex value is at negative 2 and 1. So since it's at negative 2 and 1, you need to just go ahead and make your graph. And so you make your graph. And when you make your graph, you just go ahead and go to your graph. And you go to negative 2 and 1. Put a dot there. Now we have to decide whether it opens up or down. So to decide that, we need to refer back to our original equation. So back here in our original equation, we're going to locate this value in front of our x squared. So right here, this value is positive 1. So that means that a is equal to 1. So that means that my parabola is going to open upward. So since it opens upward, I just go ahead and go to my vertex. And I draw my point at negative 2 and 1. And then I just draw my graph, my parabola, so that it's opening upward. Okay, and problem number 2, it says that we have, it says the profit that the vendor makes per day by selling x pretzels is given by the function p of x equals negative 0.004x squared plus 2.8x minus 200. So since the equation is parabolic, the maximum profit is going to be located at the vertex of the parabola. So notice that it says find the number of pretzels that must be sold to maximize the profit. So to go ahead and find the profit, the maximum profit, you're going to use that vertex formula. So notice your vertex formula is negative b over 2a. So remember that formula actually comes from the quadratic equation. The quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now when I use that entire equation, that finds my x-intercepts. But when I just use this part of the quadratic formula, negative b over 2a, that finds my maximum and my minimum values. So remember this right here, find your vertex, and your vertex is where the maximum or minimum are located out of a parabola. So there's your max, and your min are located at that point of negative b over 2a. So if you can just remember that, and all you have to do to solve this equation is you just have to take that formula, negative b all over 2a, and then you also have to remember that in your quadratic equation, this first number right here is your a, the second number here is your b, and then this is your c. So now it's just a matter of substitution. So you're going to notice that right here, we go ahead and substitute that in. So here's my here's my b value. Goes to negative, so that's negative 2.8. And then my a value was negative 0.004. Now remember, when you put this into your calculator, be very careful. And I show this to you, make sure you put parentheses around that denominator. Because if you don't, you'll get that answer incorrect. So you just plug it in your calculator. You take negative 2.8 divided by 2 times negative 0.004. And make sure you put those parentheses in there. And your answer will come out to be 350. So since the answer is 350, that means the vendor must sell 350 pretzels a day to maximize their profit. So that answer would be C. Okay, on this next problem, on number 3, it says I have f of x equals x cubed plus x squared minus 42x. And the directions just say find the zeros of the polynomial function. So whenever I want to find zeros of the polynomial function, there's several ways to find it, but the very first way that we learned how to find zeros was to factor. So remember, we're going to go ahead and factor this problem. So to factor it, I look at my equation right here. First thing I do is I set it equal to 0. That's why they call it finding the zeros. Because when you're factoring, you actually set it equal to 0, and you go ahead and solve it. So notice I set this equal to 0. And since I've set it equal to 0, I notice there's a common x squared, a common x in each equation, or each term. So I'm going to factor out that x. So notice I factor out that x. And when I do, so I've got x cubed divided by x gives me that x squared. And I got x squared divided by x gives me the x. And negative 42 divided by x gives me negative 42. So now I've factored out my greatest common factor. The greatest common factor I factored out was the x. Okay, now I want to go ahead and factor this trinomial into two binomials. So I need to find the factors of 42 that add up to be positive 1. And I notice that it's 7 and 6 are my two factors that add up to be 1. And it looks like it's a positive 1, so that's going to make that a negative 6. So notice I've now factored this down to this equation, x times x plus 7 times x minus 6. Now to find the zeros, which means to find the answers, the solutions, the roots, so on and so forth, I need to solve each one of these. So when I set each term equal to 0, you'll notice when I set x equal to 0, that's already solved. So that's why I get this answer of 0. When I take x plus 7 and set it equal to 0 and solve it, I'm going to get my x equals negative 7. So that's my second answer. And then my third answer, I set x minus 6 equal to 0. So I'm setting each factor equal to 0 to find the answer. So that's x equals 6. So there my answers are for this equation, also known as finding the zeros. So here's my answers that I just found at x equals 0, x equals negative 7, and x equals 6. So remember, each factor contains an answer, and so then that matches with C. So in my next problem on number 4, it says I've got negative 4x to the 4th, minus 2x cubed, minus 3x squared, minus 4x plus 1. And the directions say use the leading coefficient test to determine the end behavior of the polynomial functions. So the leading coefficient, which is the very first term of your polynomial, so in this case right here, you make sure it's in descending order. So here's my leading coefficient. It is, when it is in descending order, indicates what the ends of a graph does. Since the leading coefficient is negative and its power is even, it's going to go in and match number 2. So as you look at this right here, so here's all the possibilities for your leading coefficient. So notice that if that leading coefficient is positive and the power is even, so an example of this would be like negative x to the 4th, positive x to the 4th, and that means that both these ends would be going up. So on the second one, where it's a negative leading coefficient, even power, that would be like your negative x to the 4th. And not only does it apply just to x to the 4th, you'll notice that this also means all even powers. So you can write it like this. So you can write positive x, and all even powers will do the same thing on the very ends. So same thing here. This is negative x, and all even powers, their ends will do the same thing. So they're both going downward. So that's like x squared, x to the 4th, x to the 6th, so on and so forth. And then notice that on the second part, this right here is a positive coefficient with an odd power. So these are like your x to the 3rds. So if you have like a positive, you got x to the 3rd, or the 5th, or the 7th, so on and so forth. Or in other words, you could just write that as positive x to the odd. And notice that means that the left side is going down and the right side is going up. So left, down, right, up. And then the same thing that happens here if it's negative. So this is like a negative x to like the third, fifth, seventh, so on and so forth. So that means that this right is going up, or sorry, this left is going up, and then this right is going down. So you can go ahead and know what your graph is doing according to the leading coefficient test. So as you look at your multiple choice, they call it falling and rising. So notice this would be, so this would be rise. So this is left is rising, right is rising. So left up or left rises. And then on this other one, your right side is rising. So right and up mean the same thing. So same thing here. So the left is falling. And also your right would be falling. And then on these next ones, so notice on this one right here, your left falls. And your right is rising. And then on this last one, you've got the left rises. And then the right is going to be falling. So now that I know all the different cases, I can go ahead and identify in my problem the leading coefficient. So notice with this leading coefficient, I've got negative 4x to the fourth. So that means that my left falls and my right falls, because this is going to match number 2. So since it matches number 2, your left falls and your right falls. So that looks like that's going to match the multiple choice problem, A. So A would be your answer. Okay, on this next problem, on number 5, it says we've got f of x, and then it says we've got x to the fourth plus 4x cubed plus 4x squared. And the directions on number 5 says it just wants us to graph. So the very first thing you want to do whenever you're graphing a problem is you're going to find the x-intercepts by factoring. So our very first step is to factor this. In other words, we're going to find those zeros. So the first thing I notice is that there's a common x squared in all of my terms here. So that means I'm going to factor out that x squared out front. And when I do this, I take x to the fourth divided by x squared, I get x squared. When I take x cubed divided by x squared, I get 4x. And then when I take that 4x squared divided by x squared, I get plus 4. So now that I've factored it, I'm going to go ahead and factor this right here. So I need to factor x squared plus 4x plus 4. So the common numbers of 4 that add up to be 4 in the middle is going to be 2 and 2, and they're both positive. So that's going to factor to x squared times x plus 2 times x plus 2. Now I'm going to go ahead and put my x plus 2's together to put it into factored form. So when I do that, here is my factored form. So I got x squared times x plus 2 squared. I want it in that form there so I know what my graph is doing. So notice here's your answers. So the answer to x squared is going to be 0, and the answer to x plus 2 is going to be negative 2. These are your x-intercepts. So when I go to graph this, I'm going to go ahead and put those on my graph as the x-intercepts. So you'll notice I've started to graph this right here. So notice that I went ahead and took, here's my x-intercept of negative 2. And here's my other x-intercept of 0. And I put those on my graph. Okay, once you're done finding your x-intercepts, you need to go ahead and use the leading coefficient test to graph the end behaviors. So notice that my leading coefficient of this problem is right here. Here's my leading coefficient, x to the 4. So if you recall from example number, the previous one, on number 4, you'll recall that if this is a positive x to the even, which it is, we know the left is going up, or in other words, the left rises, and also my right is going up, or my right side rises. So now that I have that information, I'm going to go back to my graph here. So going back to my graph. So here's my graph. My leading coefficient was x to the 4th. So that means that both these sides are going to go up. Okay, once you've got that done, then your next step, you need to look at each factor individually to determine what each one of these are doing. So if you recall, after we're done factoring it, it looks like my problem was f of x was equal to x squared times x plus 2 squared. So here I've written the rules for each one of those factors. So notice that if this power is even, it bounces off the x-axis. And I also wrote the other rule, if the power is odd, then the graph goes through the x-intercepts. So notice in this case right here, so here is my first factor that I just did, which is x squared. So notice that this is an x squared right here. So this power is even, so that means it's going to bounce off. So here's my two ends again. My two ends were both going up. So since it's even, it's going to bounce off the x-axis, go up, make a loop, and then it's going to come down right here. And then notice right here again, this is being squared, so it's going to bounce off of that graph again. And that's what your graph will look like. Okay, on number 6, it says that it wants me to use long division to go ahead and solve this problem. So my problem is x squared plus 15x plus 56, all divided by x plus 7. So I went ahead and I set up my division algorithm. So basically, you just write the x plus 7 out front, and then underneath your division sign, you put your x squared plus 15x plus 56. Okay, and then you look at this very first term right here, and you just ask yourself, what times x will give me x squared? Well, that answer is x. Now we'll go ahead and multiply. So I'm going to take x times x. I'm going to write it right here, so this is x squared. Then I'm going to take x times 7, which is 7x. And I go ahead and put parentheses, and I subtract. So x squared minus x squared is 0. 15x minus 7x is going to give me this 8x right here. Okay, now I'm going to go ahead and bring down my next term, which is plus 56. So now that I've brought down my next term, which is plus 56, I just repeat the process. I just look at this term right here, and I ask myself, what times x is going to give me 8x? So notice that answer is 8. So that's what I'm going to multiply by, is 8 times x is going to give me that 8x. So now I just multiply again. So 8 times x gives me 8x. And then 8 times 7 is going to be 56. And I put parentheses around it. And I subtract. Now when I subtract that, I get a remainder of 0. So that means that my answer is just going to be this x plus 8. So you'll notice that that is also written up here. So this right here would be your answer of x plus 8. Okay, on number 7, now we're going to go ahead and use our synthetic division on number 7. So on number 7 it says I've got 5x cubed minus 34x squared plus 29x minus 30, and that's going to be divided by x minus 6. So the first thing you're going to want to do is write down all these coefficients. So here I've got my 5, so I write it down. Got my negative 34, I write it down. Got my 29, I write it down. And negative 30. And then I'm going to go ahead and divide it by x minus 6. Remember, x minus 6 is in equation form. So to put it in answer form, you solve it, and that answer is 6. And so that's going to go right there. And then I always put a little box right here to remind me that that's what I'm dividing by. Now that I've done that, I go ahead and follow the pattern for synthetic division. So my pattern is I bring down the 5, and then I multiply 6 times by 5, and I write that answer right there, and that is 30. And then once I'm done finding that answer, then I add those together. So I take negative 34 plus 30, and I get negative 4. Then I just repeat that process. So then I take 6 times negative 4, I get negative 24. And then I just add those together. So 29 plus negative 24 is going to be 5. Repeat that process. I got 6 times 5. That's going to give me my 30. And negative 30 and 30 is going to be 0. So when I'm done doing that, I go ahead and write down my answer. Remember, dropping it down by power, and your answer is 5x squared minus 4x plus 5. It wants us to find f of negative 3. And it says to go ahead and it says use the remainder theorem. So if you remember right, we talked about this during class. The remainder of synthetic division is the answer to direct substitution. So to find this answer for direct substitution, we're just going to use our synthetic division. And so to find your synthetic division, again, go ahead and write down your coefficients. So here's your first coefficient, which is 4. Then you got your second one, which is negative 6. You got negative 5. And then you've got positive 6. So write down your coefficients. And now we're going to go ahead and substitute in negative 3 into our synthetic division. So remember, this already is in answer form, so you don't change the negative 3. So since it's already an answer, we just go ahead and put this into our box at negative 3. And now that we've done that, we're going to go ahead and run it through the synthetic division. So remember from our last problem, you bring down your first one, so that's 4. And then you go ahead and you multiply negative 3 times 4, and that's going to give you the negative 12. And then you're going to add, so negative 6 plus negative 12 gives you negative 18. Now you repeat the process. You're going to take negative 3 times negative 18. That's going to give you 54. And then you add these together, negative 5 plus 54, which gives you 49. Okay, now we're going to take our negative 3. We're going to multiply by our 49. And that's going to give you negative 147. And go ahead and add those together. So 6 plus negative 147 gives you negative 141. So that is your remainder. Notice I always put a little box right here to remind myself that is the remainder. So now I know that the answer to f of negative 3 is the same as my remainder. So here's my remainder, negative 141. And so I know that f of negative 3 equals negative 141. So that matches the answer of C. Okay, on number 9, it gives us this equation. It says we have x cubed minus 3x squared minus 18x plus 40. And it says use synthetic division to divide f of x equals x cubed minus 3x squared minus 18x plus 40 by x minus 2, and then use the result to find all zeros of f. So in other words, I'm going to go ahead and find all the answers to my equation. So notice again, I write down my coefficients. So here's my first coefficient of 1. Here's my second coefficient, negative 3. Here's my third coefficient, negative 18. And there's my last coefficient of 40. So now notice this right here is an equation form, so the number that I'm going to put in is the number 2. Because when I solve that equation, when I solve it, the answer is 2. So I go ahead and do my synthetic division. So do your synthetic division. You go ahead and bring down this first term, which is 1. And multiply. 2 times 1, you're going to get 2. And then add. So negative 3 plus 2 is negative 1. Repeat that process again. So you have 2 times negative 1, which is going to give you that negative 2. And then you add that together, and you're going to get negative 20. And now you go ahead and repeat the process. So 2 times negative 20 is negative 40. Add that together, and you get your remainder of 0. Okay, now that I've done that, you're going to notice that that represents my equation. So far I factored this. I factored it to x minus 2. And notice this will be your 1x squared, your minus x, and minus 20. Okay, now we can go ahead and factor this again. So this is x minus 2. Your factors of negative 20 that add up to being negative 1. So you're going to notice this, negative 5 and 4. So I factor this to x minus 5 times x plus 4. Now I can go ahead and find all my zeros, all my solutions, all my roots, all my answers. So when I solve each one of these individually, you're going to notice this, of course, x minus 2 set equal to 0, you get 2. X minus 5, you get 5. X plus 4, you're going to get negative 4. So your solution set is going to be 2, 5, and negative 4. And so that's going to match the answer of D. Okay, on this next problem on number 10, it says that we have f of x is going to equal 5x to the third minus x squared plus 3. So the direction says use the rational zero theorem to find all possible rational zeros for the given function. So remember to find all your possible rational zeros. All you have to do is just remember that your possible rational zeros is just the last term factors, all of the first term factors. So as I look at my last term, so here's my last term at 3. So here are my possible factors of plus minus 3 and plus minus 1. Remember, factors are numbers that go into another number evenly. So the two numbers that can go into 3 evenly are 3 and 1. So you'll notice that I now list the factors of my first term. So here's my first term, which is a 5. So all my possible factors that go into 5 is plus minus 5 and plus minus 1. Now, some books call them P and Q, and they just say, well, it's just P all over Q is your possible rational factors. So you're going to notice I go ahead and here is my first term factor of plus minus 1. And then here is my other first term factor, which is, so that's plus minus 1 all over plus minus 1. And then also I have plus minus 1 all over plus minus 5. And then I've got plus minus 3 all over plus minus 1. So that gives me this set. And then my last set, I've got my plus minus 3 all over my plus minus 5. So those are all my possibilities. I've got plus minus 1 all over plus minus 5. I've got plus minus 1 all over plus minus 1, plus minus 3 all over plus minus 1, and plus minus 3 all over plus minus 5. Now when I simplify that down, of course, you're just left with plus minus 1/5, plus minus 1, plus minus 3, and plus minus 3/5. So that answer is A. When I look at number 11, number 11 says I've got f of x equals x cubed minus 6x squared plus 9x minus 4. And it says find a rational zero of the polynomial function, use it to find all the zeros of the function. So notice again, here's all my possibilities. So here's my last term factors of plus minus 4, plus minus 2, and plus minus 1. Here's the possibilities of my first term right here, which is just plus minus 1. So you're going to notice that when I put them over each other, so plus minus 4 all over plus minus 1. I'm going to put plus minus 2 all over plus minus 1. And plus minus 1 all over plus minus 1. Those are all my possibilities. So here's all my possible factors. So I've got plus minus 4, plus minus 2, and plus minus 1. So now to figure out which factors are the actual factors of that equation, you just have to remember that factors, their remainder is 0. So factors, remainder is 0. So to figure this out, I'm going to use my synthetic division, and I'm going to find which of these numbers have a remainder of 0. So I go ahead and I substitute in. So I write down all of my coefficients. So you'll notice that here's your first coefficient. So I'm doing synthetic division now. So here's my coefficient of 1. Here's negative 6. Here's positive 9. And then negative 4. So I write down all my coefficients. And I'm just going to substitute it in and see which ones have remainder of 0. So notice that I go ahead and put in the 1 here, and I run it through my synthetic division process. So if you remember right, your synthetic division says you bring down the first one, you multiply. So I'm going to multiply 1 times 1, put it up here, and then I'm going to add. So that comes out to be negative 5. I repeat that process again. So now I take 1 times negative 5, I get negative 5. Now I add that together, I get a positive 4. And I go ahead and take 1 times 4, I get 4, I add that together, and I get a remainder of 0. So that means that 1 is a factor of that equation of x cubed minus 6x squared plus 9x minus 4. So now I go ahead and take a look at this. So here's my equation right now. So if you remember right, the 1, the equation that gives you 1 as an answer, is going to be x minus 1. And then this is 1x squared minus 5x plus 4. So I'm going to go ahead and factor this again. So factoring x squared minus 5x plus 4, factors of 4 that add up to being negative 5 is going to be negative 4 and 1. So here's my factors, negative 4 and negative 1. Those are the factors that add up to this negative 5. So that's going to factor down to x minus 1 times x minus 4 times x minus 1. Or in other words, here's all my answers. So my answer to x minus 1 is going to be 1. This is 4. This is also 1. So when I go to write them down, I just have the answer 1 and 4, and that matches up with A. Yeah, number 12. It says list all possible rational roots, use synthetic division to find an actual root, then use this root to solve the equation. So notice that in this problem right here, just like we did on our assignment, sometimes you just list them out, substitute them in, but you can also use your graphing calculator to help you to find that root. So you just take your graphing calculator and go to y equals, clear out anything that's in there. Go and type in that equation, x to the third. And it says we have plus 5x squared. And then it says we have plus 12x and minus 18. Hit your graph key. And you'll notice that since x-intercepts and roots and answers and solutions are all the same thing, you're going to notice that this has an x-intercept of 1. So that means that 1 would be a factor, or would be an answer to my equation. And you're going to notice that it doesn't go through the x-intercept anymore. So we know that looking at this problem, that using our fundamental theorem of algebra combined with the linear factor theorem, we know that we have to count for 3 answers. So only one of those answers is going to be an integer answer. And then the others, we're going to have to go ahead and find on our own. So to do that, you go ahead and use synthetic division. You write down your coefficients. So here's my coefficients of 1, 5, 12, negative 18. Okay, now I'm going to go ahead and take this 1 out. So using your synthetic division process, we've already talked about this before, so I'm just going to kind of go through it rather quickly. Bring down the first term, multiply, then add, multiply. 1 times 6 is 6. Add that together, you get 18. 1 times 18 is 18. And you'll get 0 as your answer. So I know it's a factor because that remainder was 0. So I've got this equation. So here this is our equation. I've got x minus 1 times x squared plus 6x plus 18. So you're going to notice that there are no factors of 18 that add it to be 6. So that means I'm going to use my quadratic formula. So don't forget your quadratic formula. Your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember that a is equal to 1, b is equal to 6, c is equal to 18. And now we're just going to go ahead and substitute those into our quadratic formula. So putting in the 6, I get negative 6 plus or minus the square root. And I've got 6 squared minus 4 times my a, which is 1 times 18. And that's all over 2 times my a, which is 1. Now that I've done that, I can go ahead and simplify this down. So simplifying this down, you're going to notice that 6 squared is 36. And negative 4 times 1 times 18 is negative 72. And then when I subtract those two, I'm going to get the square root of negative 36. So this comes out to be square root of negative 36 is plus or minus 6i. And then, of course, for my denominator, I've got the 2 times 1, which is 2. So I get negative 6 plus or minus 6i all over 2. Now notice you have a common number in all 3 terms. It has to be in all 3 terms. If it isn't, you can't divide by it. So I'm going to divide everything by 2. So negative 6 divided by 2 is going to be negative 3 plus or minus 6i divided by 2 plus or minus 3i. And then 2 divided by 2 is just going to be 1. So there's my 2 missing answers, negative 3 plus or minus 3i. And notice that's the reason why it didn't show up on your calculator. So remember, imaginary numbers, so if you look at your calculator, imaginary answers or solutions are not x-intercepts on your graph. So here's my 3 separate answers. So my 3 separate answers is 1, negative 3 plus 3i, and negative 3 minus 3i. Looks like I forgot to change that. And so that matches up with D. So you got 1, negative 3 plus 3i, and negative 3 minus 3i. On problem number 13, it says to find an nth degree polynomial function with real coefficients satisfying the given conditions. So we've got 5 and 2i are zeros. So we need to remember that there is a missing 0. We need to remember that imaginary answers occur in conjugate pairs. So that means that if I have 2i as a 0, I will also have its conjugate pair, which is negative 2i. Okay, now that I've written down all my zeros, I'm going to go ahead and write equations for each one of my zeros. So here's my 5. So the equation that 5 is a 0 comes from is x minus 5. And here is my 2i. So the equation that 2i comes from will be x minus 2i. And the equation for negative 2i would be x plus 2i. Now that I've written all of my equations, I'm just going to go ahead and FOIL this out to find my original equation. So here's my equation for my zeros. I've got x minus 5, x minus 2i, and x plus 2i. So I'm going to go ahead and FOIL out my x minus 2i and my x plus 2i. You always want to FOIL out your imaginary equations first. And when I do that, for my first, here's my x times x, which is going to give me x squared. So remember, outsides is going to be x and 2i, so that gives me 2ix. My insides is going to be negative 2i and x, so that's going to give me negative 2ix. And then my lasts is going to be this negative 2i, positive 2i. So here's my lasts, and that's going to give me negative 4i squared. So now that I'm done FOILing this out, so notice that 2ix and negative 2ix, those across out, that's just 0. And remember, I squared is equal to negative 1. So when I change that to negative 1, this negative 4 times negative 1 is going to give me positive 4. So the equation for x minus 2i and x plus 2i, that equation is actually x squared plus 4. And here's my x minus 5. So now I'm going to go ahead and FOIL those together. And when I FOIL those together, doing first outside, inside, last, I end up with this equation right here. So here's my firsts. I've got x times x squared. That's going to give me x cubed. And then my outsides is going to be x and 4. So multiply those two together and I get 4x. Then my insides is going to be negative 5 and x squared. So that's going to give me negative 5x squared. And then my lasts is negative 5 times 4. And when I multiply those together, I get negative 20. So using FOIL to find that answer, I get x cubed plus 4x minus 5x squared minus 20. And then just always get in the habit of writing everything in descending form, which just means that your powers go from 3, 2, 1 to 0. And that would be your answer. Your answer is going to be x cubed minus 5x squared plus 4x minus 20. Looking at this next problem, it says we've got h of x equals 2x over x plus 6. And the directions just say find the domain. So remember, domain is when we can't have a 0 in our denominator. So notice, to find this domain, I'm going to take this denominator, which is x plus 6. I know that that can't equal 0. So that means that x cannot equal negative 6. So notice that x can't equal negative 6. So that is my restriction. And then the rest of this just means that all other x's will work. So that matches A, which says all other x's will work except for x cannot equal negative 6. And so that is our domain. On number 15, it says we got this equation, f of x equals x minus 1 over x squared plus 1. And then it says find the vertical asymptotes, if any, of the graph of the rational function. So remember, to find vertical asymptotes, you're going to set the denominator equal to 0. So that is my rule for finding vertical asymptotes. So I'm going to take my equation, x squared plus 1, and I'm going to set it equal to 0, and I'm going to solve it. And I just need to make sure it doesn't cross out with a numerator factor, which it doesn't. So there is no numerator factor that it crosses out with. So I can go ahead and solve x squared plus 1 equal to 0. So when I solve this, notice I subtract 1 from both sides. So I get x squared equals negative 1. Then I'm going to go ahead and take the square root of both sides. So taking the square root of both sides, I get x equals plus minus I. So that means that this answer came out to be imaginary. And we know that imaginary answers do not show up on real graphs. And so since that's the case, my answer would be D, which is there are no vertical asymptotes. On this next problem, on number 16, it says I have f of x equals negative 2x plus 7 times 4x minus 3. And it wants me to find the horizontal asymptotes, if any, of the graph of the rational function. So remember, to do that, the rule is you're going to compare the numerator power with the denominator power. So that's my rule. So here's my numerator power, which is 1. Here's my denominator power, which is also 1. Now once I make those comparisons, then I just have to follow the rules for finding horizontal asymptotes. So here's the rules. The first rule is if the numerator power is less than the denominator power. If that's the case, then your horizontal asymptote is going to be 0. My second rule is that the numerator power equals the denominator power. Then my horizontal asymptote is the numerator leading coefficient divided by the denominator leading coefficient. And then my third rule states if the numerator power is greater than the denominator power, if that's the case, then there is no horizontal asymptote. So those are my 3 rules that I need to follow when finding horizontal asymptotes. So I'm going to look back at my original equation here. So here's my original equation. So my original equation, this numerator power is 1, this denominator power is 1. So that means that they are equal to each other. So that means that I'm going to go ahead and follow that rule, which says that I need the numerator leading coefficient divided by the denominator leading coefficient. So your leading coefficients are the first numbers that come up. So now as I look at my problem, so that matched my second rule. So here again I state my numerator power was equal to my denominator power. So if you remember right, that was -2 all over 4. So my horizontal asymptote would be at -1/2. So that answer is B. On number 17 just says it wants me to graph the rational function. So since I'm going to graph this rational function, that means that I have to find both my vertical asymptotes, so I abbreviate that VA, and I need to find my horizontal asymptotes. I abbreviate that HA. So remember again, to find your vertical asymptotes, you go ahead and take the denominator and set it equal to 0 and solve it. So I'm going to take my denominator, 5 plus 3x, set it equal to 0, and I'm going to go ahead and solve it. So when I solve it, I subtract 5 from both sides. So subtracting 5 from both sides, I get 3x equals -5. Then I'm going to divide both sides by 3, and I get x equals -5/3. So there's my vertical asymptote. Now to find my horizontal asymptote, I'm going to use those previous rules that we just talked about. So whenever you're using those rules, though, you always want to make sure that it is in descending order. So notice this is -5, and I'm just going to rewrite this as 3x plus 5. So remember, I look at my numerator power. So this numerator power, even though I can't see it, is 0. I compare it to my denominator power, which is 1. So I know that my numerator power is less than my denominator power. So since that is the case, if I refer back to my rules that I wrote down before, so here's the rules. This matches this rule right here, which says that the numerator power is less than the denominator power, your horizontal asymptote is 0. So as I go back to my problem, you're going to notice I have now stated that in this problem right here, my numerator power is less than my denominator power, so my horizontal asymptote is at 0. So now that I know that, I can go ahead and start to make my graph. So if you remember right, this right here, and I'll just write it down here so we can see it. So my vertical asymptote, and I'll just abbreviate that, VA, that was at -5/3. And my horizontal asymptote is at 0. So now to graph this, I go to my vertical asymptote, so I go to -5/3, so I just estimate that. So -5/3 is going to be about -1 2/3. So I go -1 2/3 and I make a dotted line here. And my horizontal asymptote is at 0. Even though I wouldn't be able to see it, it's going to be sitting on that axis. So I'll make it the best I can with this pen right here. Okay, now if you remember right, we know that our basic shapes for our rational functions, so this is our basic shape, which looks like this and this, but we also know that it can be switched. So in other words, it could be this or it could be the top one. So one or the other, and it could be one or the other. So top or bottom. So to figure out which one it is, you're just going to refer back to your original equation. So here's my original equation right here, which is -5 all over 5 plus 3x. I'm just going to find myself a point. I'm going to plot that point. So I'm going to go ahead and find a point over here on this side. So I'll just choose this point right here, which is x equals 3. I'm going to take that x equals 3 and I'm going to go ahead and substitute it into my equation. So if you remember what your equation is, my equation was -5 all over 5 plus 3x. So here's my equation, -5 all over 5 plus 3x. I'm going to go ahead and substitute in this point. So this point that I chose right here, so I didn't put my negative sign in there. So that point is -3. So I'm going to find the y value, and that's going to tell me where that shape is located at. So I substitute -3 into this equation. I get 3 times -3 is -9. -9 plus 5 is going to be a -4. And that's going to be -5 divided by -4, which is going to be a 5/4. So that means here, 1, I'm going to be at 5/4. So 5/4 is about 1 1/4. So that would be somewhere right up in here. So that's how I know that on this side, my graph would be on top. So on this other side, I'll just go ahead and choose a point right here. So I'll choose 0. Going to substitute into that equation. That equation again was -5 all over 5 plus 3x. If x equals 0, I'm substituting that in. So this is going to be -5 divided by -5. So that is y equals -1. So here is 0, I'm down here at -1, and so that's my other part of my graph. So that's how you graph a rational function. Okay, looking at number 18. So number 18, it says y varies directly as z, and y equals 288 when z equals 18. Find y when z equals 10. So remember, this is a direct variation problem. And our direct variation problems, we always have to remember to put in this right here. This is known as our constant of variation. I like to think of it as a type of slope. So your objective on this problem is to actually find the value of k so that we can actually substitute that in and use that for our equation. So notice that since it says that y equals 288 when z equals 18, I can figure out what k is by using substitution. So in place of y, I'm going to put 288. In place of z, I'm going to put 18. And so I end up with the equation 288 equals 18k. So now I can find my slope, also known as the constant variation, just by dividing both sides by 18, which is what I do next. I go ahead and divide both sides by 18. And I end up with my slope or my constant variation being 16. So now that I know that that's my slope, I can go ahead and substitute that in. And here's the equation that I'm able to work with. Y equals 16z. Now it says in your directions, find y when z equals 10. So now to find y when z equals 10, I'm going to substitute this in. And when I substitute that in, I end up with my equation. And my equation is y equals 16 times 10. I multiply that together and I get y equals 160. So the value of y 1 equals 10, that answer is C, which is 160.